Today I'm going to do a quadratic pattern. When we hear a wage quadratic, we think about x squared plus bx plus c, but now we're going to talk about the pattern. So the pattern is going to be tn equals en squared plus bn plus c. So this is a standard form of a quadratic pattern. So let's go ahead and see how it works. It's very simple. So let's say we have this sequence here. Consider the following sequence. It starts with 5, second term is 12, and third term is 21, and the fourth term is 32. So the first question says, write down the next term of the sequence. Okay, let's see what are they doing to get the next term here. So I'll just go ahead and find my first differences. Quadratic pattern will always have the second difference. We see a quadratic pattern by second constant difference. Second difference is going to be constant or common, right? So that is what differentiates arithmetic sequence from quadratic sequence. Arithmetic sequence, it has first common difference, and this one it has a second common difference, right? So let's go ahead and find our first differences first. 12 minus 5 is 7, right? 21 minus 12 is 9, and 32 minus 21 is 11. So you see we don't get a constant difference here. So when we don't get this constant difference, we'll go ahead and subtract again. 9 minus 7 is 2. 11 minus 9 is 2. Now we get constant difference, right? So you see this number is going to repeat itself. Now if here is 2 and here is 2, so we're gonna get 2 again here. So we got 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 is 13, right? So I can get the next 10 here for doing much work. So this question is typically 1 mark, and this one is usually 4 marks. This one can be 4 or 3, depends. So we're adding, so it's going to be 32 plus 13, which is 45. Now we got the next term for the first. So the first question says write down the next term of the sequence. Therefore the next term is going to be 45. You can go on, you can do this forever. It's 2 here, is gonna be 2 here. You can do this forever. 13 plus 2 is 15, then we get the next term. 45 plus 15 is 60. You can do this forever. So that's how the pattern works. Pattern is repeats itself forever. Determine the formula for the nth term of this sequence. Now we are looking for the nth term. So we got general steps we use here. So that is why my first step is to label my quadratic pattern or my spider web here. So at the bottom I'm going to have 2a, in the middle I'm going to have 3a plus b always, and at the top I'm going to have a plus b plus c. So you must memorize these short equations here or expressions. 2a at the bottom, 3a plus b in the middle, a plus b plus c at the top. So let's go ahead and so at the bottom I have 2a is equals to, I'm going to use the first numbers. I'm going to equate them to the first numbers in my web here. So 2 is going to be equals to 2. Then I solve for a. When I solve for a, I'll simply divide both sides by 2. A is going to be 1. Now I got the value of a. So I work upwards. So in the middle I have 3a plus b is equals to 7. Remember we take the first number, don't take 9 or 11, we take the first number. So it's going to be 3, but we know the value of a. Value of a is 1, so I'll go ahead and plug it here. When I see at 1, then I can solve for b, right? 3 multiplied by 1 is 3. Then we take 3 to the other side, it becomes negative. Therefore b is going to be 4. Now we got the value of a and the value of b. So let's go ahead and do the last part at the top. The a plus b plus c is going to be equals to 5. Remember, we got the value of a here, which is 1 plus, and the value of b here is 4 plus c. Okay, 1 plus 4 is 5. Now we're gonna transpose that 5 to that side. There is gonna be 5 minus 5, which is 0. Now we got the value of a, the value of b, and the value of c. We can go ahead and plug into our general formula. Remember, I wrote it there at the top, is an squared plus bn plus c. So we just got the value of a. The value of a, when I see a, I'm going to write 1. Therefore is going to be 1n squared, which is n squared, and b is going to be 4, which is 4n, and c is 0. Don't need to write c, therefore we just got our general answer. Easy as that. Let's go ahead and do the last question. Last question says, which term of the sequence is 725? Now we're given the value of the term is 725, but then we don't know the term number, right? The question says which term. We don't know that term, but we know that term is going to have 725. So just write our formula. First step, right? So we know that term is going to be equals to 725, right? So now our task is to find the value of n. But with a circle, here we have a quadratic pattern, right? And this one is this is quadratic. Whenever we have quadratic, we'll write it in the standard form. Whenever I have squared, something squared, I'll write my equation in the standard form, right? Standard form meaning I'll put everything on one side. Right, so take 725 to that side is going to be negative 725, which is equals to 0. Remember, I took 725 this side, therefore I'm left with 0 here. Right, so I can use a quadratic formula here. So quadratic formula, remember, is negative b plus or minus b squared minus 4ac all over 2a. Let's go ahead and substitute. The value of b is the coefficient of, remember, the value of b is the coefficient of x, but here instead of x we have n here, right? So the value of b is going to be the coefficient of n, which is 4 plus or minus b squared is going to be 4 squared minus 4a is the coefficient of n squared, which is 1, and c is the constant, which is negative 25 all over 2 into a, which is 1. We can get the values of n. Right, it's going to be 25, and this one's gonna, the other one is gonna give you the negative answer, right? Therefore we pick the n is close to 25. Then we're done.